Good morning, good afternoon, good evening, whenever you may be. Guess what? It's another exciting episode of 8th grade science, live from the Brenna Bunker, somewhere in the quarantine, Southeast United States. It's Ace Academy, 8th grade science, hosted by your favorite Mr. Brenneman here, rocking it out from Streamside today, talking about water quality. One of the things that we talk about, the last couple of days, again, we're talking about the environment and everything else. Today we're talking about the characteristics that actually make up water quality. What makes water quality? So it says we talk today, so it says we can identify the physical and biological characteristics that indicate water quality. So our first thing we're going to talk about are the physical characteristics. Remember, water quality is the description of the chemical, physical, and biological characteristics of water. Let's highlight that. Water quality is the description of the chemical, physical, and biological characteristics of water. You probably need to know that. Water quality been given as good or poor. You can just say, that's good water. That's poor water. I mean, basic indications. But water quality can also be said to be polluted or clean. But whatever the qualification given, the factors that go into it remain the same. Then we're going to talk about the physical and biological components. We'll talk about the chemical piece tomorrow. Start with, we're going to look at temperature. Water temperature is important to the species of things that exist in that water. Too warm or cold, and they can experience stress or even perish. Some fish can only reproduce in a very narrow temperature band. The water's outside the band when they're supposed to reproduce, they won't. If this happens over a broad area, entire populations of fish can be threatened. So the warmer water is, the more solid substances that will be dissolved into it. Warmer water cannot hold as much dissolved oxygen as cold water. Organic matter decomposes faster in warmer temperatures. This increases the decomposition of aqueous nutrient concentrations, causes eutrophication. Most commonly realized is algae blooms, which block sunlight for underlying aquatic plants. So, I mean, there's all kinds of things that can happen with a change just in temperature. So the abundance of algae is an easy food source for aerobic microbes that soar in population. It's in population. And further deplete the dissolved oxygen. So aerobic means, guess what? Yeah, guess what? Aerobic, they're using oxygen versus anaerobic, which means non-oxygen using. So these aerobic microbes are using the oxygen because they're eating the algae, and they further deplete the dissolved oxygen. Low oxygen levels create hypoxic dead zones that cannot support most aquatic organisms. Not enough oxygen in the water to support life. Higher temperatures increase the metabolic activity of many aquatic organisms. As a result, these organisms need more food to keep them going. If their environment is not capable of supplying this food, then the organisms will suffer from malnutrition. Most sources of temperature thermal pollution come from power plants. Power plants use the water to cool their systems and then discharge the warmer water into the lake or river they took it from. So typically where you'll see thermal pollution is somewhere where there's an industry or a power plant. Lake Norman's got a nuclear power plant. Lake Wylie has Catawba Nuclear Station. And years ago, when I was a kid, we lived in Lake Wylie and we had a boat. And so in the winter, when my dad would say, hey, we're going to go fishing, it's not something we did a lot of, but we do it on occasion. So we would go down to where the nuclear plant was and where they discharged their water back into, from the cooling towers back into the lake. Where they did this, that water coming out was warmer. And the fish tended to be a lot more active in that warmer water than in other places in the lake. So even in the winter, you could go down there and fish in that warmer discharge water and catch more, more fish on a regular basis than you could anywhere else in the lake in the winter. And so that's just kind of one of those things that you kind of work out. But so the warmer, but since they came out, those fish would hang out around that warmer water, were more active. Now, were fish active in other places in the lake? Yeah, sure, but not nearly as active as they were in that warmer water. Now, was it really warmer? I mean, it was a couple degrees warmer. I mean, it was 10 degrees. But when the water is 40, 10 degrees only bring it up to 50. So it's not like you're swimming in it. Not like it's a jacuzzi, but it does make those fish that are in that area a little bit more active. Keeps their metabolism a little bit higher. Next thing we're going to look at is turbidity. Now, turbidity, is a measure of how clear water is. So when you go to look at turbidity, you're looking at water. Um, you're talking about, is it clear? Is it murky? You see water right here. So you got stuff coming in this way, and you got clearer water over here. And here's where it's mixing together and going on down that way. So you can see here in this high level shot, you can see all the stuff flowing out into the water. Same thing over here, kind of clear water right there, but all this junk's coming down. Here's a great example: low turbidity to high turbidity. Clear water to stuff, water's got stuff in it. Now, is that stuff automatically pollution and nasty? No, it could just be soil. Just filter it out to drink the water, but it could be other things as well. So here's another one. Low turbidity, high turbidity. You see the junction of these two rivers. This one's got a lot of mud and stuff coming out of it. This one, a lot less. So turbidity, again, is just how clear the water is. Turbidity is caused by particles suspended or dissolved in the water that scatter the light, making the water appear cloudy or murky. Particulate matter can include sediment, especially clay and silt, fine organic and inorganic matter, soluble colored organic compounds, algae, and other microscopic organisms. So there's a ton of things that can be floating around in that water in there. So the more suspended solids are, the less transparent it is. High turbidity is a sign of poor water quality. It can be associated with organic pollution. That might include pathogenic materials. High turbidity can also lead to temperature increases as the water then absorbs more energy from the sun. So again, so this water goes from being clear, which the sun's, kind of energy will pass through because there's nothing to absorb it, really, to having all these things in there. Remember, darker things absorb, that black car is hotter than that white car. Same thing. So the darker the water is, the more energy it absorbs from the sun, the higher the temperature. So high turbidity can lead to temperature pollution. So a report of the European Inland Fisheries Advisory Commission lists 5 ways that fine particles can have a harmful impact on freshwater fish. It acting directly on the fish, killing them or reducing their growth rate, resistance to disease, or etc. Preventing successful development of fish eggs and larvae. Modifying the natural movements and migrations, reduces the amount of food available, and affects the efficiency of the methods for catching fish. So, I mean, there's all kinds of things that, that turbidity plays into, like as far as, water, how poor or good the quality is. And also your judging of quality depends on what you're judging it for. If you're trying to drink it, your judgment is one way. If you're trying to just fish in it, your judgment's probably a little bit different. So turbidity is measured using a specialized optical equipment in a laboratory in the field. The light is directed through a water sample, and the amount of light scattered is measured. This unit of measurement is called a nephelometric turbidity unit, or NTU, which comes in several variations. The greater the scattering of light, the higher the turbidity. Low turbidity values indicate high water clarity. High values indicate low water clarity. So turbidity, amount of stuff in the water. Lower the amount of stuff, the better the quality of water. Last physical quality of water is movement. If a body of water is moving, is considered safer than a body of water that is stagnant. Stagnant, important word here. Stagnant is a body of water that is not moving. Stagnant water is prime for infestation by harmful bacteria and insects. It can also collect runoff from surrounding areas and concentrate the levels of animal feces and chemicals that wash into it. So if you've got some sort of pond that that the water doesn't it doesn't flow in and out of, it just kind of collects the rainwater and just sits there, and then but all that stuff that washes into it stays there. So all the dirt, crud, and oils from the cars and dog poop and cat poop and everything else washes into this thing. The water gets eventually evaporated out. That's how the water gets out of it, and more water stuff washes in. So the concentration of stuff in that water goes higher and higher and higher every time stuff gets washed in, and the water evaporates out. When it evaporates out, it doesn't take anything with it. Evaporated water, that water vapor is just pure water. It takes none of the contaminants with it. So as over time, that stagnant water just becomes more and more containing of all these things that have been washing into it. And between the animal crap and the chemicals, it's not good for anybody. And then you add in the insects and whatever else that lay eggs and mosquito larvae specifically. You go put a can of water out somewhere during, in mosquito season, and within a couple of days you're looking down in it. You see all these little bugs, these things moving around the water. Those are mosquito larvae, which will turn into adult mosquitoes before too long. And hey, we all love adult mosquitoes, right? Yeah. So stagnant water, not a good thing to have laying around. So now we go into biological indicators. So those are the physical indicators. Physical indicators. Now we're going to talk about the biological indicators. Biological indicators of water quality are called bioindicators. The presence, condition, and numbers of the types of fish, insects, algae, plants, and other aquatic life. Well, there's your list of bioindicators right there. Fish, insects, aquatic plants, and aquatic life. Covers it all, right? Those things, everything can basically, that lives in the water can be considered some sort of bioindicator. Provide accurate information about the health of fresh water, coastal, and marine water. Bioindicators include living macroinvertebrates. So a macroinvertebrate, macro means what? Large. As opposed to micro, which means small. Macro means large. Invertebrate means it doesn't have doesn't have a spinal cord. So we're talking macroinvertebrates. We're talking about shelled things like crayfish, crawfish, shrimp, those type of things. So when you find macroinvertebrates in a they're easy for people to collect and identify. So lay people, not scientists, can go out into a pond or stream in a given area. They can look and see, all right, how many of these things can we find? The more you can find, the better the water quality. The less you find, the worse the water quality. Many macroinvertebrates are sensitive to pollution in the water. They're a good indicator of whether a body of water is livable or not. It's not always possible to test water quality and keep it under observation at all times and places. These bioindicator organisms are altered by changes within the local environment and show these changes in their genetics or physiology. While direct sampling of water, basically when you go down and get a bottle of water, take it back to the lab and go, what's in this water, and have a machine, tell you, here's all the things that are in it. You can't do that like constantly. So bioindicators provide an estimated timeline of past environmental conditions. So all right, so one time we go there and we go, all right, we found 54 crawfish right here in this square, 5 meter square. But today we went and found 10. A, we know the numbers are down. B, and then we could take 1 or 2 of those crawfish back to the lab and we can check on their condition and see what's going on with them. So then we find, are they fat? Are they thin? Are they malnourished? Do they have obvious, lesions, or their shells not forming right? Those kind of things. And those things will give us a timeline of what's happening with things in that body of water. So, the time scales can depend on the species chosen to be the indicator. And as an example, if you have a reduced abundance of marine microorganisms with a darkening of coral pigments, that shows you a reef may be exposed to poor water quality for an extended period of time. So depends on what it is as to how much information it gives you and what time frame it gives you in. So if you just go visit a body of water, twice a year, and count the shrimp or the crawdads or the corals or whatever else in a certain spot, you return to the same spot every time. You would take water back to sample to see what's going on right then. But again, it's a flowing body of water. That water is not there. That piece of water is not there all the time. It flows in and out. So, the condition of these bioindicators can give you a timeline as to what's happening over a longer period rather than just testing the water as right there. So bioindicators are the living things that tell us what's going on. And then we have physical indicators as well, whether the water is moving or stagnant, turbidity, and temperature, that help us determine what water quality is. So I can identify the physical and biological characteristics that indicate water quality. So temperature, turbidity, water movement for the physical, and biological is just the bioindicators, the animals and things that are living there and what they tell you. All right, so make sure you like the video, give me a big thumbs up. Make sure you put your name, say hey to me in the comments, counts as your attendance for today. And once again, subscribe to my channel so you know when this stuff pops out. We'll catch up with you guys tomorrow. Have a great rest of your day.